Let's focus on why we want to use approach 2. Suppose we want to compute this thing, which is b to the power this huge number mod c. This huge number happens to be 1 followed by 51 zeros. Using approach 1, we will need about 10 to the power 51 multiplications. For approach 2, we are going to use a little bit of observation to see how many steps would be needed. So what I'm going to observe is 2 to the power 10, which is 1024, is roughly equal to 10 to the power 3, which is 1000. So I can make the observation that 10 to the power 51 is roughly 2 to the power 170. So that means we will need about 170 times 2 multiplications, that is 340 multiplications. So that's quite a bit, but it's something that we can do fairly easily with a computer. In cryptographic applications, we need to compute something like this. So here we have b to the power 2 to the power 512. Note that the exact number will not be 2 to the power 512, but it would be in the vicinity of that number. So if I use approach 2, I will need about 512 times 2, roughly 1024 multiplications. Again, quite a bit, but fairly feasible. If I use approach 1, we have a problem. We will need 2 to the power 512 or 2 to the power 1024, these many multiplications. So let's just focus on the smaller of these numbers, which is this one. So 2 to the power 512, I can use what I just did earlier. I have basically 2 to the power 510 times 4. So I'm going to rewrite this as 10 to the power 153. Now, if you are not sure how big this number is, I want to put some context. 10 to the power 80 is roughly the particles in the known universe. So we're talking about numbers that are way bigger than even the particles in the universe. So that's something that means that we will not really be able to use in practice. By contrast, approach 2 is feasible. It will require quite a bit of work, 512 or 1024 multiplications, etc. But it's not something that is impossible to do with computers. And that's why we are looking into this method of how to compute large powers, and we will see the use of it in the next couple of modules. Once again, we have reached the check before you go ahead slide. I want you to find how many multiplications would be needed for all these numbers. Again, the answer is something that you should be able to compute. But the key thing I want you to get is the thing that is written at the bottom, which is that as long as the number of operations we're doing is small enough, it's feasible, we can do it. So in this case, as long as you're getting answers that are smaller than, say, 20, you would be doing it correctly. We have reached the end of the module, so I want you to go ahead and do the review quiz. Note that you're expected to just provide the answer for the review quiz, but you will be expected to show your work if you're going to do these kinds of problems in the exam.